Alright, so the main part of this lesson is the mean value theorem, but we're going to start with a specific case of the mean value theorem. And that case is Rolle's theorem. Now, both of the theorems, you have to have a continuous and differentiable function. Okay? So if the y-coordinate of the initial point is equal to the y-coordinate of the terminal point, and it's continuous and differentiable, that means that somewhere, so if you go down, somewhere you're going to have to come back up. And when you do, you're going to get a horizontal tangent. Or if you go up, you're going to have to come back down. And so when you do that, you're going to get a derivative equal to 0. Okay? So that's what Rolle's theorem says. If your y-coordinates are the same and you're continuous and differentiable, you have a derivative that equals 0 somewhere. Now this thing could be going like the sine or cosine curve. It could be going crazy in between there. But at least once, it has to come back up or back down and give us a horizontal tangent. So let's start off just simply. It says give 2 reasons why Rolle's theorem might not apply. Well, they're highlighted right there. So number 1 would be it's because it was not continuous. So if you think about it, if we had those 2 points and everything was fine, we were going, but then we had a removable discontinuity, so that's the place where it was supposed to be 0, where we get that horizontal tangent line, but it doesn't exist right there. So we're not going to get that derivative that we want there of 0. And the other one was not differentiable. So again, if we started and ended at the same place, and we went up like this, but then we came back down with a corner, we're not going to get that derivative equal to 0 there. So those would mess that up. So let's see what we have here. So this is telling us find 2 x-intercepts of the function. Remember, that's where y equals 0. X-intercepts where y equals 0. And show that the derivative has to equal 0 at some point in between them, in between the 2 x-intercepts. Now this is not highlighted because you're not going to have to do this first part, but it's good practice for us. So the first thing we want to realize is that this should be continuous and differentiable. It's not, there's nothing weird happening there. So that's our first consideration. So let's let y equal 0 and find those intercepts. So if we set that equal to 0, we set f of x equal to 0, then x is going to be -3 or 0. So f of -3 equals f of 0 on the interval from 0 to 3. So we know, and it's continuous and differentiable, so we know that Rolle's theorem applies. So by Rolle's theorem, f prime of x has to equal 0 somewhere in there. Okay, so let's move that up a little bit. All right, so if we take the derivative of that, hopefully you notice that's a product rule. Okay, product rule. So we're going to take the derivative, and the derivative of the first thing is 2, and now I'm going to use, when I multiply by the second thing, I'm going to rewrite that to help me take my next derivative. So derivative of the first thing times the second thing, plus the first thing times the derivative of the second thing. So that's going to be 1/2 x plus 3 to the -1/2. Alright, so these 2's are going to cancel, and I'm going to set that equal to 0, and I'm going to deal with that negative exponent over there. It's going to be x over x plus 3 to the +1/2. Okay, so now what we're going to do is get a common denominator here. So I'm going to multiply by x plus 3 to the 1/2 over x plus 3 to the 1/2, because that equals 1. And when I do that, it's pretty nice. This happens a lot in calculus. Stuff simplifies nicely. So we're going to end up with this. And I want to be careful there. That's supposed to be the exponent. It's starting to almost look like a normal 1/2 on the side there. So just be careful. Don't get too careless there. So that's going to be 2x plus 6 plus x. That's going to be 3x plus 6. And that's going to reduce to, I should have put that over there, got it out of the way. That's going to reduce to 3 times x plus 2. All right. And if we, and that's all going to be over x plus 3 to the 1/2. So if we set that equal to 0, then that's going to be 0 when x equals -2. So x equals -2, and that is in the interval from -3 to 0. Okay, so we just showed that f prime of x equals 0 for x equals 2 in that interval. Okay. All right, so let's try that again. So we're going to need to factor out of that. So it looks like we can factor 10 out of there. I'm going to set that equals 0. We could just divide both sides by 10 right there, but that's 6x squared minus 13x minus 8. So that's going to be, if you remember how to factor that, we're going to do 1/6 and then 6x and 6x. And this is negative, so one's going to be negative and one's going to be positive. And so a times c is -48. A times c. Now we need factors of 48 that are going to subtract to give 13. So 3 and 16. If you're not sure, start listing them all until you get a couple that work. So 3 and 16, I want that to be negative, so that means I want the 16 to be negative and the 3 to be positive. So I can factor 3 out of here. So that's going to be 2x plus 1, and I can factor a 2 out of here, 3 out of here, and a 2 out of here. So that's going to be that. And if we set that equal to 0. Now when you factor out the 3 and the 2, that cancels out the 1/6. So our y-intercepts are going to be, our x-intercepts, sorry, are going to be -1/2 and 8/3. So our interval is -1/2 and 8/3. Okay, so now we want to take, so according to Rolle's theorem, because, and this is a polynomial, so it's continuous and differentiable. So Rolle's theorem should apply here because the y value equals 0 at both of those points, so we should have a derivative that equals 0 somewhere on there. So if we take f prime of x and we take the derivative of that, so that would be 120x minus 130. And if we set that equal to 0 and divide out a 10, we're going to get 12x minus 13. So that's going to be 13 over 12. And that's in this interval. That's a little bit more than 1. And this interval goes all the way up to 2.67. So that's in there. So we could say x equals 13/12 is the value of c where f prime of c equals 0. So that might have been a better way to express that answer over there. All right. Hopefully that wasn't below the camera there. All right, so now this is a little bit different. This is more likely what it'll look like. So determine whether Rolle's theorem can be applied, and if it can, then find the zeros. So they're going to give you the values here. That's why this one's highlighted, because it's highly unlikely they'll have you find the y-intercepts first. They'll probably just give you the values. So step 1. Now, step 1 is f of 0 is going to be, actually there's something else we could do here, but so f of 0 is 0 over negative 2, which is 0, and f of 4, that's going to be 16, that's going to be 0 over 2, which is also 0, so that works. But then the question is it continuous and differentiable? Okay, so x equals 2 is a vertical asymptote, and that is on the interval from 0 to 4. So it's not continuous on 0 to 4. So we can't really do that. We can't use Rolle's theorem because it's not continuous. So that's determine whether no, we can't. So let's try it again. So over here, and maybe you say, well, maybe we should have checked that first, but so maybe step 1 should be we have a vertical asymptote at x equals negative 2, but we're just looking from 0 to 4. So on 0 to 4, we are continuous. We're okay. So now we want to test f of 0. That's going to be 0 over 2, which is 0. And if we check f of 4, we're going to get 16 over, or we're going to get 0 over 6, which is 0. So the endpoints are equal. And then we also could have checked if it's differentiable, and it is. Because a hyperbola is going to be fine there. Okay, so what we need to do now is find the values of c where the derivative equals 0. So that just means take the derivative and set it equal to 0. So f prime of x. So chapter 3 is going to give us a chance to practice some of the stuff we were supposed to learn in chapter 2. So those of you who maybe weren't as focused as you should have been in chapter 2, we are going to learn some new things, but we're going to be using derivatives to learn about new things. So that's going to allow you to practice. So that's the quotient rule. So I told you the quotient rule starts with low and ends with low. So low d high minus high d low, which would just be times 1 over low squared. Okay, so we're supposed to set that equal to 0, and if we multiply this out, that's going to be 2x squared plus 4x minus 4x, that's going to cancel out, minus 8, and then minus x squared plus 4x. Okay, so that's going to be x squared plus 4x minus 8 over this. Now, that numerator doesn't factor. You should be able to figure that out pretty quickly because your factors are going to be 1 and 8 and 2 and 4, and no combination of those is going to give you a 4 there. So that means that we have to use the quadratic formula. We're setting that numerator equal to 0. So again, they're not going to ask for this on the AP exam because it would take too long. They're not really worried about the quadratic formula. They want to know the calculus stuff more, but you may need the quadratic formula for some other class, something, so we're just going to remind you of that. Alright, so that's x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Alright, so that's going to be negative 4 over 2 over here. And if we work on that square root, that's going to be 16 plus 32, that's 48. That's 16 times 3. So that's going to be 4 root 3 over 2. So that's going to be negative 2 plus or minus 2 root 3. So that's going to be negative 2 plus 2 root 3 and negative 2 minus 2 root 3. So our interval was from 0 to 4. So if you think about it, 2 root 3, if we square that, that's 4, that's root 12. 2 root 3 equals root 12, which is 3 point something. So you're going to have negative 2 plus or minus 3 point something. So negative 2 plus 3 point something is going to be 1 point something. Negative 2 minus 3 point something is going to be negative 5 point something. So in the interval from 0 to 4, negative 5 point something is not really going to work for us. So we just need to worry about negative 2 plus 2 root 3. So the value of c, where the derivative equals 0, is negative 2 plus 2 root 3. Alright? Again, not really going to be a quadratic formula in there, but okay, so the mean value theorem, again, continuous and differentiable. Make sure on the AP test, if you are mentioning the mean value theorem, that you have to say that it's continuous and differentiable. Now remember, if it's differentiable, then it's automatically continuous, but not necessarily in reverse. So if the AP exam says it's differentiable, you can say it's continuous because it's differentiable. Okay, so if you look here, we have the same 2 points. The endpoints are not equal this time, but what we're saying is that whatever the slope is between the initial points, that's somewhere we're going to have that slope again. If this is continuous and differentiable, somewhere it has to go back up, and there has to be a point where it has to come back down, and when that happens, it's going to have that same slope. Now, if you apply that to Rolle's theorem and you think about it, that slope was 0, because if the y coordinates are equal, the slope between those is 0. So it's really the same thing. And I don't really know why we even need Rolle's theorem, because if you do the mean value theorem, you would get the same answer. When you go to calculate the slope, you're going to get 0 when you're doing Rolle's theorem. But anyway, so pretty easy thing to do. You're just going to calculate the slope between the endpoints and set the derivative equal to that slope. Okay, so again, sketch a graph where the mean value theorem would not apply. So if I have these 2 points here, I'm going to actually do 2 of these, one for each, just like I did on Rolle's theorem. So if this so if it's not continuous, so this might go up like this, and this could go down like that, and it never has, these slopes are steeper, it never has that slope in between there. Okay, there is no tangent line, there's no derivative that matches that slope because it's not continuous. Also, this goes up like that and then back like that. There's no place where that matches that slope. So there's 2 examples. All right, and 3 more to go here. So, can the mean value theorem be applied to f on the interval from a to b? If it can, find all the values where the derivative equals that slope between there. So first of all, it's a polynomial, which means it's continuous and differentiable. So that's good. Now, number 2, what we need to do is find the slope. So what we need to do is find f of 2 minus f of 0 over 2 minus 0. So f of 2, do that over here on the side. It's a good idea to write stuff down and see what's going on. So f of 2, that's going to be 8 minus 4 minus 2 plus 1. So that's going to be 3. And 0 is probably going to be nice. That's going to be 1. All right. So, and then that's going to be over 2. 2 over 2 is 1. All right. So now we're going to take the derivative. So a lot of students miss this, and I don't really know why, but you're just calculating the slope using those 2 points, and then you're taking the derivative. So that's going to be 3x squared minus 2x minus 1, and then you're setting the derivative equal to that slope. So 1 equals x squared minus 1. So you set that equal to 0, subtract 1 from both sides. Now, this is a little awkward because that doesn't factor again. So we're going to use the quadratic formula on that again. So x equals the opposite of b. So this would be a good place for you to pause and practice this just to make sure. It might have been a while since you've done this. X equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. 2 plus or minus, that's going to be 4, that's going to be 24, so that's going to be 28, which is 4 and 7, so that's going to be 2 root 7, and that's over 6, so that's going to be 1/3 plus or minus root 7 over 3. So root 7 is greater than 2 but less than 3, so let's think about what that means. We're going to have 1/3 plus root 7 over 3 and 1/3 minus root 7 over 3. So that's more, or that's more than 2, so that would be a negative. If we subtract those, that's going to be about like this more than 2/3. So 1/3 minus more than 2/3 is going to be negative. So that one's going to be out. So this is the value we want here because that is in the interval from 0 to 2. Okay. So sine and cosine are continuous and differentiable. Okay, so that's good. And now we need to calculate the slope. So that's going to be the sine of 0 minus the sine of negative pi over 0 minus negative pi. So the sine of 0 is 0. The sine of negative pi is also 0. So that divided by pi, that equals 0. So actually, this is Rolle's theorem, but it shows you that it's the same process. If you were to calculate the slope in Rolle's theorem, you'd get 0. And then what are you doing? You're setting it equal. You're setting the derivative. Well, let's do that. So the derivative of this is cosine. Hopefully everybody's good with that. So we're setting that equal to 0. So the cosine, the derivative set equal to the slope, just like we did here. The derivative equal to the slope. derivative equal to the slope. So that's going to occur. It says from negative pi to 0. So that's going to occur at, so cosine at 0 starts at 1. If we go to the left and it comes down, that's going to be at negative pi over 2. Negative pi over 2 is in that interval. So there we go. All right. And finally, let's wrap this up for today. So 2003, number 80. This was on the AP Calculus test. Multiple choice question. Now there's only 4, 1 right answer and 3 wrong answers. Not answers, they're called distractors. But back then there were 5 total choices. All right, so first of all, you see it says continuous and differentiable. So that's a decent hint that they're talking about one of these things here. Here's the interval. And it says that equals negative 5 and that equals 4. Which of the following statements could be false? So that's where it gets a little bit tricky. Could be false. Just like sometimes they say must be true. So that's what makes it a little bit trickier. All right. So there exists C somewhere in that interval such that f of C has to equal 0. Okay, so it went from negative 2 to 1 and it was continuous. So that should remind you of something. That's the intermediate value theorem. Okay, that's the girl's height. If the girl goes from 2 feet to 5 feet, she had to be all the heights in between 2 and 5 feet. Okay, so that's the intermediate value theorem. That has to be true because it's continuous. Okay, because it's continuous, that has to be true. There exists a C somewhere that the derivative has to be 0. That would be if these two were equal. That would be Rolle's theorem. Okay, that would be Rolle's theorem, but our y coordinates aren't equal. So that, or actually that would be the answer. I should cross off the other one. That can't be false. This, I think, absolutely is false. But let's keep going. There exists somewhere in between there. Oh, was I looking at? I was looking at the wrong thing. Sorry about that. Up here, when I said I was looking at negative 2 to 1. Actually, I should have been looking at negative 5 to 4. But still, somewhere between negative 5 and 4, it has to be 0. It's the same reason. I just was looking at the wrong numbers. It just happened to be true for both of them. Okay. So 3, that's the same thing. If we're going from negative 5 to 4, it's going to have to be 3 somewhere in between there. So that's the intermediate value theorem again. So that can't be false. Somewhere the derivative has to equal 3. Well, that would be the mean value theorem if it applies. I mean, it does apply, but if it equals 3. So let's check that out. So that's going to be 4 minus negative 5 and 1 minus negative 2. So that's going to be 9 over 3, which is 3. So that's the slope between the endpoints. So that's the mean value theorem. So yeah, that's true. Somewhere the derivative has to equal 3 because the original slope is 3. All right. And then finally, there exists a number such that f of c is greater than f of x for all values in the closed interval. Now, we don't use it that much, but we did mention it. That's actually the extreme value theorem. So that says that if you're continuous and whatever you do, it means there has to be a biggest and a smallest value, including the endpoints. So it might just be the endpoints. So that might be your extreme minimum, and that might be your extreme maximum. But somewhere there has to be there has to be a minimum and maximum somewhere if you are continuous. You don't have to be differentiable for the extreme value theorem, and you don't have to be differentiable for the intermediate value theorem. All right, so that wraps that up. It's about that time. Have a good day.